So you've set up a brand new Ubuntu machine, you sync the Android source, you type make, and it fails instantly. Why can't a fresh operating system build the world's biggest operating system? Here is what actually happens under the hood. The AOSP build system is a massive, intricate machine that relies on hundreds of very specific system-level tools, not just the defaults. Notice the highlighted line here? It confirms that even a perfect LTS install isn't enough to get started. Now, let's look at the master command that installs all the missing pieces. How do you install hundreds of specific compilers, libraries, and utilities without spending all day on it? You use the master key. Google provides this single, enormous apt-get install command that you see highlighted on screen. This one line is your entry ticket. It pulls in everything from core development tools like Git and GCC to obscure libraries needed for very specific build steps. You run this once and it prepares your host machine to speak the AOSP build system's language. But just running it isn't enough. Let's break down what some of these critical packages actually do. Ever wondered how Android turns a simple text file defining a hardware interface into complex working C++ code during the build? It's not magic, it's parser generators. Look at the highlighted packages, Bison and Flex. These tools are fundamental for code generation. They read grammar and definition files, for example a HIDL file that describes how the camera HAL talks to the framework, and automatically write the low-level C++ boilerplate code that connects them. This saves thousands of hours of manual coding. Next, let's look at a package that seems old but is still foundational. Now, if modern AOSP uses the Clang compiler and the Ninja build system for speed, why does this dependency list still insist on installing the classic build essential package? Most people trip over this because it seems redundant. The reality is that while the main OS compilation uses the modern toolchain, the build environment itself needs to be bootstrapped. Many of the initial setup scripts, host tools, and legacy modules still rely on the foundational GNU tools like GCC and Make that this package provides. Think of it as the scaffolding needed before the skyscraper can be built. But speaking of legacy, let's talk about 32-bit libraries. Here's a question that stumps new engineers. Why are we installing 32-bit libraries on our powerful 64-bit build machines? The answer is cross-compilation and proprietary binaries. As the highlighted text explains, AOSP is built for ARM phones on x86 computers. Sometimes a silicon vendor like Qualcomm provides a critical tool, say for signing a modem firmware image, that is only compiled as a 32-bit binary. Your 64-bit Ubuntu host cannot execute that binary without these 32-bit compatibility libraries. Without them, the build just stops dead. Now let's see how the build system wrangles thousands of XML files. Android's configuration is not one file. It's a web of XML manifests spread across more than 800 Git repositories. So how does the build system merge them all without errors? It uses the specialized tools you see highlighted here, libxml2 utils and xsltproc. These are not simple text editors. They are powerful command line utilities for parsing, transforming, and merging XML data structures. The build system uses them to intelligently combine the base platform manifest with device-specific overlays to create the final correct configuration for the exact product you're building. But what about the most important tool of all, the compiler? If the compiler is the most critical tool, why do we deliberately avoid installing it from Ubuntu's package manager? The trick that took me 3 years to learn is that build reproducibility is non-negotiable at Google. As this section explains, to guarantee a build is identical on every machine worldwide, we ship the exact versions of Clang, Python, and Ninja inside the AOSP source tree itself in a directory called prebuild/. This ensures my build in Mountain View produces the exact same binary as your build in your home office, eliminating an entire class of impossible to debug bugs. You can even run these tools yourself. So where are these pre-packaged tools actually located? Here is what actually happens under the hood. The build scripts don't just call Clang, they call a full explicit path. Look at the command highlighted on screen. It's not just running a command, it's executing a binary from a very specific versioned path inside prebuild/clang/host/linux-x86.
You can cd into that directory in your AOSP checkout right now and run that command to see the precise compiler version that will build your OS, completely independent of your host system's tools. But what if the build still fails?
We've all been there. A build fails on the first line with a cryptic error like command not found or a missing SO library. Most people trip over this because they immediately suspect a bug in the Android build system. The reality, as this text points out, is that you are almost certainly just missing a system package on your host machine. This is especially common when you're building a non-standard device that has extra dependencies not covered by the main list. The key is to read the very first few lines of the error log carefully. But how do you find the package you need? So the build log says a command like M4 is missing. But how do you know which Ubuntu package provides it? You don't guess, you use a specific tool for the job. Look at the highlighted section here. The trick is to use apt-file, a utility that acts like a search engine for the entire Ubuntu package database. You run apt-file update, then apt-file search /bin/m4. It will tell you the exact package name, in this case M4, and you can then install it with sudo apt install. This simple process can resolve 99% of those initial build failures. Now that your environment is solid, let's talk about the next critical dependency, Java.
Enjoyed the video? Hit like and subscribe for your regular dose of AOSP customization. Thanks for watching. See you in the next one.